Okay, so now let us get to the trigonometric integral. Okay, so now of course, couples identities. Um, if you remember, that will really help you to do some problems in these sections. Okay, so then this is something that you need to remember, and also of course go back to like last quarter, right? When we try to take the derivative. Okay, okay. Then, of course, I didn't write down the derivative of sine is equal to cosine, and the derivative of cosine is negative sine, right? Okay, anyway, then now here is a couple integrations that just remember that again, remember the derivative of negative cosine of u is a sine of u, right? So this is just what you should know. Okay, so however, one thing that is I would like to show is how about the integration of tangent of u du. This one is equal to the natural log of secant of u plus c. Okay, and of course, a couple of this. Okay, I would like to show you this one and this one. So these two is basically is really similar to what I will show you then. Okay, okay, so let us try to do this one is I would like to show that the integration of tangent of x dx is equal to L natural log of absolute value of secant of x plus c. Okay, okay, so let's see how do we actually do this. Now let us start with the left hand side. Okay, remember this is actually is one way that we could prove is we started from one side, we start with the integration of tangent of x dx. Then now we know that tangent of x basically is sine of x over cosine of x, right? Okay. And some of you actually know that probably we are going to use substitution now. So we are going to let u equal to cosine of x, and du is negative sine of x dx. Okay. Okay. So therefore, in this case, then you will see that one thing about this is we know that sine of x dx is equal to negative du. Okay, so then let us go back to the problem now. What I'm going to do here is I would like to work with this one is integration sine of x dx is du over cosine of x is u, but don't forget that we have a negative right here, right? Okay, and of course we know that this one is negative natural log of u plus c, right? Okay, then if we continue, then it will be negative u is cosine of u, I'm sorry, cosine of x, okay, plus c. Then of course we know that if I have negative, basically what we could do here is we could make it become natural log of absolute value of cosine of x to the power of negative 1. Okay. Then you will see that why we have secant. Okay, which is equal to the right hand side. So then this is actually is the idea. Okay. Now the next example is a slightly a little bit different. Okay. We need to work with again we start with the left hand side. But in this case, I'm not going to work with 1 over cosine of x. Instead, I'm going to multiply top and bottom by secant of x, tangent of x. Okay. So this is actually is one of the technique. Oh, secant of x plus tangent of x. Okay. Now, once I do this, then what we have here is we are going to have secant square x plus secant of x tangent of x over secant of x plus tangent of x. Okay. And now what we are going to do is I would like to let u equal to secant of x plus tangent of x. Okay. The reason is you will see that here the u will be secant of x tangent of x plus secant square x. Okay, then now you will see all of this basically just du then, right? So I will have du over u. And of course, in this case, I will have natural log of u plus c. Okay. Then we know that u is secant of x plus tangent of x. Okay. So again, if I want to prove the integration of secant of x equal to natural log of secant of x plus tangent of x plus c, then this is actually is one way to do this then. Okay, so now let us get to the exercise now. Now, to some of the problem, you may see that you have sine of x to some power or cosine of x to some power. In this case, how do we actually take care of the integrations? What we need to do is actually we need to remember that the derivative of sine of x is cosine of x, okay? Or the derivative of cosine of x is equal to negative sine of x. This will help you to use the substitution to finish the problem. So in this case, for example, like number 3, then you will see that here, what I'm going to do is I would like to decompose the sine of x to the power 5 into sine of x to the power 4 times sine of x. Okay. And now you will see that what happened to this, I will be able to rewrite this into sine square x to the power square. Okay. Now, remember, sine square x is 1 minus cosine square x. Okay. And now, we are going to let u equal to 1 minus cosine square x. Okay. Then you will see that the derivative du is equal to I'll make it too complicated. So I will let u equal to cosine of x. The reason is du equal to negative sine of x dx. Right? Then I have this. Okay, then now I will have 1 minus u square to the square multiplied to negative du. Okay. So of course, to this one basically is 1 minus 2u squared plus u to the power 4. Then it will be negative. The integration of 1 is u minus 2u to the q over 3 plus u to the 5 over 5 plus c. Okay. And of course, we could rewrite this into negative cosine of x plus 2/3 cosine cube x plus 1/5 or negative minus cosine fifth x plus c. Okay, yeah, that's it. So this is the answer here. Okay, so when now go ahead and try to see if you could work on number 4. Okay. Okay, so then to number 4, it is equal to integrate between 0 to power 2 and cosine square x times cosine of x dx. Okay. And of course, we know that cosine square x is 1 minus sine square x. And you will see that let u equal to sine of x, then du will be cosine of x dx. Okay. And now, and if x equal to 0, then u equal to sine of 0 equal to 0. If x equal to power 2, u is sine of power over 2, which is equal to 1. Okay. So therefore, to this one, basically, let us rewrite this. So I will have it, remember this is, we change it to u now, right? U is between 0 and 1 of 1 minus u squared du. Then, of course, right now, I will have u minus u to the power 3/3 integrate between 0 and 1. Okay. Then I have it 1 minus 1/3, which is equal to 2/3 then. Okay. So how would you do number 5? Okay. So now to this one right here, now if you think of, you let u equal to tangent of x, then when you take the derivative, you will have secant square x dx. Then in this case right here, it seems that we do not have any secants, right? So it seems that we could not use the substitution right away. Okay, so let's try to see if we could factor, okay? And then that means we have to find a way to change the form, okay, of the integram to see if it helps, okay? If you remember that 1 plus tangent square x is equal to secant square x, then now we could actually do this problem now. Okay. Then we could use substitution, let u equal to tangent of x, then du will be secant square x dx now, okay? Then of course, right now, I will have integration of u squared du now, right? Okay. Then we substitute back. Then I will have 1/3 tangent cube x plus c. Okay. Yeah. Okay. And now, another one is, what if we have kind of like do not have any power, just cosine pi x times cosine 4 pi x dx. Okay. So in this case right here, if we have a multiplications, I hope they remember that we could change it to the sum of either side or cosine, right? So then here is one thing that remember that, okay? So this is what we're going to do in this case right here, okay? So again, we are going to find a way to change the integrand, okay, to help us to do the integration. So then I will have cosine of pi x plus 4 pi x and plus cosine of pi minus x minus 4 pi x. Oh, this is plus dx. Okay, and now we are going to have 1/2. This is cosine of negative 3 pi x plus cosine of 5 pi x dx. Now, one thing about this is, do you remember that cosine function is even functions? So it means that this one right here basically is just cosine of 3 pi x plus cosine of 5 pi x dx. Okay. And now then it will be here. Of course, you could use substitution, but if you remember that this one is basically is 1 over 3 pi sine of 3 pi x plus 1 over 5 pi sine of 5 pi x plus c. Okay. Then, of course, the last step here, it will be just simplify it then. Okay, yeah, that's it. So now I would like to show you like some technique. If you see the multiplication of sine of x to some power times cosine of x to some power, how do we actually take care of it? Okay. Now, one way to do this is if the power of the cosine is odd, okay, that means it's in the form of 2k plus 1, then what we are going to do here is we are going to take out one of the cosine of x, okay, and then to work with kind of like substitution then, okay. And of course, change everything in terms of sign. Okay, so another one, if the sine function is odd, then what we need to do is, again, we are going to take out one of the sine of x, okay, make it even, and then make everything in terms of cosine, okay. Then we will let u equal to cosine of x and do the substitutions. Okay. So then this is how we take care of if cosine is odd and also sine is odd. How about if both of them even then? And now we have to work with the reduction then, okay, the power reductions. We reduce the power, okay, to make it become cosine square x is equal to 1/2 1 plus cosine 2x, go with the double angle, okay? And then cosine square x is equal to 1/2 1 plus cosine 2x, okay? So then this is actually is one thing. And of course, if you remember that sine of 2x is equal to 2 times sine of x cosine of x, then this is actually another useful identities that you need to remember, okay? Then let's see how do we actually work out the example number 7, okay? Now you will see that to example number 7, both of the power, they're even. So meaning what, in this case, I'm not going to work with A and B, I should work with C then, okay? Then now, maybe let us work on this one on the sketch, okay, to simplify. What is cosine square y, sine square y equal to? Okay, so then let us work it out here. Okay, so I have cosine square y times sine square y, which is equal to 1 plus cosine of 2y over 2 times 1 minus cosine of 2y over 2. Okay, and of course, in this case right here, I will have 1/4 1 minus cosine square of 2y. Okay. Then, if you remember that cosine square of 2y is equal to 1 plus cosine of 4y over 2, okay, a power reductions. Okay. Then we will be able to work it out, this problem now. Okay. Then, of course, this one right here, it will be 1/2 minus cosine of 4y over 2. Or I would like to make it become 1/8 minus 1/8 cosine of 4y. Okay. Okay. So then now we could actually work it out here is 1/8 minus 1/8 cosine of 4y. Okay, so then this one, it is equal to 1/8 y plus 1/8 minus times 1/4 sine of 4y. Let's see. Then, okay, so it is 1/8 y minus 1/32 sine of 4y plus c now. Okay. Okay, so then let us check number 8. Okay, number 8, we find that sine of y is raised to the power of odd power 3. Okay, so therefore in this case, we are going to work with the path B. Okay. So I'm going to have this is cosine of 498 y sine square y and sine y dy. Okay. Then now what we need to do is we have to change this one times 1 minus cosine square y. Okay. Okay. And now we are going to have this is cosine 498 y minus cosine 500 power, right? Okay. And then times sine of y dy. Okay. And now what we want to do, we would like that u equal to cosine of y. Then du is negative sine of y dy then. Okay. Then now we are going to change this one. Okay. So I will have u to the power of 498 minus u to the 500 times negative du. Okay. So it is equal to negative u 499 over 499 plus u 501 over 501 plus c. And of course, this is equal to negative over 499. Okay. Okay, so I will have this is u is cosine 4 power 99, right? 499 y over 499 plus cosine y raised to the power of 501. Okay, plus c. Okay. Okay, so then this is actually is the idea. Okay. Okay. Then how about tangent and secant now? So the idea is really similar to the sine, cosine, okay? And then let's check this out. If secant is even, the reason is the derivative of tangent of x is secant square x, right? If secant is even, then we are going to use A. If tangent is odd, then we are going to work with B, let u equal to secant of x. The reason is the derivative of secant of x is secant of x tangent of x. Okay? And now check this out. So to this one right here, of secant is even. So therefore, to this one right here, we are going to work with the A. Okay? So then let's see how do we do this then. So I will have integrate between 0 and pi over 4. Okay. And now I'm going to decompose the secant to the power 4 into secant square x, tangent to the power 4, and then secant square x. Okay, do this. And then now what we want to do is we want to change this, okay, to, remember 1 plus tangent square x is equal to secant square x, right? The identities. Okay. Okay, and then now we will have tangent to the power 4 plus tangent to the power 6. And now you know that we are going to use a substitution now. So we will add u equal to tangent of x, then du is secant square x dx. And also is if x is equal to 0, then tangent of u, okay, tangent of 0 is equal to 0. If x is equal to power 4, then tangent of power 4 is equal to 1, okay? And I will have this is u equal to 0 and u is equal to 1 here. Then I have u to the power 4 plus u to the power 6 du now. Okay. And the rest of the problem is kind of easy. So we will have this one is u to the 5th over 5 plus u to the 7 over 7 plus c. Oh. I wrote with the definite integral. Huh? So then now we will have 1 over 5 plus 1 over 7. So we will have 12 over 35 then. Then now, how about number 10? Now you will see that in this case, I have tangent and secant, they both odd, meaning tangent is odd. So if tangent is odd, then we are going to use what with B. Okay, so this is the one. Then I will have this one. I'm going to change this one to tangent square theta, secant square theta. And we will have tangent theta, secant theta, d theta now. Okay, then now you will see that the derivative of secant of theta is tangent theta, secant theta. So what I need to do here is I will change this. Okay, so tangent square x basically is secant square, theta minus 1. Okay. And now I will have secant to the 4th power minus secant square. Okay, then now we are going to let u is equal to secant theta. Then du secant theta, tangent theta, d theta. Okay, then now I will have this one is u to the 5th over 5 minus u to the 3rd over 5 plus c. And of course, the answer will be secant to the 5 power minus secant to the 3 power. Oh. Wow. Okay, let's see. So far, so good. Okay. Okay, so then now you will see that that's it for these lectures. So basically is the derivative of the trig functions. So the key, again, you have to remember some of the identities that you learned in PCAL2, okay? And like the power reductions, like the Pythagorean identities, okay? And again, the products, right? Okay, product to sum. Okay. And, yeah, that's just it. Okay, so again, practice more. Okay, so to get familiar, how do we actually take the trig integrals? Okay, thank you.